Welcome to Sundar's lecture. This is lecture number 102, and in this lecture we are going to continue two-port network. See, we have left some topics in the two-port network, and in this lecture we are going to continue the two-port network topics. In this particular lecture we are going to see theory of symmetry. See, what we have seen in the previous classes, we have seen theory of reciprocity, right? So I just want to refresh the contents whatever we have seen in the previous class related to two-port network, because we have continued three-phase circuits and we have went for coupled coils, and then we have came again here because we have stopped with this reciprocity. But I want to continue to tell you what is theory of symmetry, and then we will go for series connections of two-port network, parallel connections, cascaded connections, and we are going to design a transformer using two-port network, and we are going to design gyrator using two-port network, right? So we will go deep into two-port network. Then only you can understand what is the application of the two-port networks, right? See here, this is what we have seen, right? Theory of reciprocity for two-port network. The condition we have seen this one, right? V1 by I2, that means first port voltage by the second port current. The ratio of first port voltage to the second port current and second port voltage to the first port current. That is the if you equate these two, you will get the condition for reciprocity, and we have seen for all the parameters, right? For Z parameter, for Y parameter, H parameter, and ABCD parameter. And in this particular lecture, the same conditions, not same condition, it is like same thing, same procedure we are going to follow here for this one, theory of reciprocity, theory of symmetry. And what is the condition for theory of symmetry here? Condition, I will write down the condition like what we have done there. First port network, first port voltage to the second port current, the ratio. But here it will be first port voltage divided by first port current, which is equal to second port voltage divided by second port current. That's all. This is the condition. This is the condition for symmetry. Symmetry, right? This is the condition, and we will take one by one, right? First we will go for EZ parameter, EZ parameter. See, I am not going to draw the diagram again and again, because you know this is the common diagram for all the two-port networks, and the parameters will differ, right? So first, what is EZ parameter equation? V1 is equal to EZ11 I1 plus Ez12 I2. This is the first equation. This is the first equation. And what is the second equation? V2 is equal to Ez21 I1 plus Ez22 I2, right? So this is the second equation, right? So we know these two equations already. And see here, one thing I want to clearly tell you, you have to understand this one. See, if you want to find this ratio, V1 by I1 is equal to V2 by I2. So I need to find what is the ratio of V1 by I1, and I need to find what is the ratio of V2 by I2, and then I need to equate these two equations. First, one thing, you can do it by two ways. Either you make I1 is equal to 0 and I2 is equal to 0. That means you are going to short circuit this, open circuit this port 2 so that I2 is equal to 0. And you find what is the ratio of V1 by I1 or V2 by I2. And you open circuit the port number 1, that means I1 is equal to 0, and find what is V2 by I2 or V2 by I1, any one, right? You will get two equations and you equate that one. That is one procedure you can do. Or if you want to do it in another procedure, you have to make V1 is equal to 0 and V2 is equal to 0. So if you are going with current procedure, make I1 is equal to 0 and I2 is equal to 0. If you are going with the voltage equation procedure, you just make V1 is equal to 0 and V2 is equal to 0. Simply you do any one of this one to get this V1 by I1 and V2 by I2. That is the procedure. See, here I am going to, because which one it will be very easy, you can do by anyone, because if you do here I can make voltage is V1 is equal to 0, so the equation becomes I1 and I2, right? I1 and I2, and if I make V2 is equal to 0, again the equation becomes I1 and I2. So there is no, I cannot get V1 by I1 and V2 by I2. So what I am doing here, I am going to put I2 is equal to 0. I2 is equal to 0 in equation number 1. Equation number in equation number 1. Simply, you put I2 is, which means what I am doing, I am just open circuiting the port number 2 and supplying the voltage here, so that what happens to the two port network. See, these kind of things we have already seen many a times, so I don't need to explain these kind of things, right? If I put I2 is equal to 0, then this equation will go off. What I will get, V1 is equal to Z11 into I1. That's all. This will go off, right? So I will straight away get this equation, right? So V1 by I1, which is equal to what? Z11. That's all, right? This is equation number 3. See here, I've just got straight away I am getting what is the value of V1 by I1. So if you're putting I2 is equal to 0, then you have to put I1 is equal to 0 in the two equations to get the V2 by I2. So don't put V2 is equal to 0 here. Don't put like that, right? If you are going with I2 is equal to 0, then put I1 is equal to 0, right? So I1 is equal to 0 in equation number 2. Straight away I will get right again. What you will get here, what you will get here, if you do so in the equation number 2, this I1, this will go off, this will go off. So you will get V2 is equal to Z22 I2. So I can write down V2 by I2, which is equal to Z22. This is equation number 4. See here, this is the condition. You have to equate 3 and 4. 3 equate to the equation number 4. What you will get? Z11 is equal to Z22. That's all. See here, the condition, it is very simple to understand too. See, what is the condition? If you want to say this two port network to be symmetry, find Z parameters. Z11, Z22, Z33, Z44. But if you see the value of Z11 equal to Z22, then you can conclude this two port network is a symmetry, which means the port 1 impedance, that means V1 by I1 is what? It is an impedance, right? Port 1 impedance is equal to port 2 impedance, source impedance. V1 by I1 it is source, V2 by I2 it is load. Simply you can see, simply you can say that, right? So this is the condition, right? So we will go for the next one right now. What is that? Y parameter, right? I will take it down. So what is Y parameter equation? Y parameter. So y parameter, you know equations, right? What is the equation? It is I1 is equal to y11 v1 y11 v1 plus y12 v2, and then what is I2? It is equal to y21 v1 plus y22 v2, right? So this is equation number 1 and this is equation number 2. And you see here too, what you do now, we need to find again the same thing. I am not going to write again and again, right? This is what we are going to find, these two ratios, right? So now what you do, here you see, if I put V1 is equal to 0, V1 is equal to 0 here, if I do so, V1 is equal to 0, if I put here, so what I will get? V2 by I1. I will get V2 by I1. See here, one minute, you see, if I put V2 is equal to 0, if I put V2 is equal to 0, then I will get V1 by I1. If I put V1 is equal to 0, I will get V2 by I2. See, try to understand, right? Either you put I1 is equal to 0, I2 is equal to 0, or V1 is equal to 0, V2 is equal to 0. So here, what I am going to do, put V2 is equal to 0 in equation number 1, simply. Simply you do this, what you will get? V2 is equal to 0. What I will get? I1, which is equal to Y11 V1. That's all. So now what you do? V1 by I1, that is what I need, right? So V1 by I1, put this one here, this one here. What you will get? So this ratio V1 by I1 will be is equal to 1 divided by Y11. This is equation number 3. So this is this one, right? So what you do now? The other thing, So what you do now, put v1 is equal to 0, put v1 is equal to 0 in equation number 2. Equation number 2, what you will get, this v1 will go off. So you will get I2 is equal to y22 into v2. So if you bring this one like v2 by I2, v2 by I2 which is equal to 1 divided by y22. This is equation number 4, right? This is equation number 4. And you see, if I equate equation number 3 and then 4, simply what I will get, it is a 1 by y11 is equal to 1 by y22. And finally, I can write y11 is equal to y22. Y11 is equal to y22. Same thing. Whatever we have get in Z parameters, and you again what you do, find the Y parameters here, and if you do so, you will get Y11, Y12, Y2122, and if you see Y11 and Y22 are same and equal, then you can conclude that two-port network will be in symmetry condition. That means the port 1 impedance and port 2 impedance are same, self-impedances, right? Or you can say driving point impedances. We have seen those kind of things. Anyhow, see, we will go for the H parameter now. See, what is the equation for H parameter? Tell me the equation. What is this one? So you can write V1, which is equal to H11I1, H11I1 plus H12 V2, right? H12 V2. And here it is I2 which is equal to H11I1 plus H12 V2. Sorry. This one H21I1 plus H22V2. So this is equation number 1 and this is equation number 2. So here, see, again I am going to do V1 is equal to 0 and V2 is equal to 0. You can do like that. So first what I will do, I will go for V2 is equal to 0 in equation number 1, because I have V2 in equation number 1 as well as in equation number 2. Anyway, I will put V2 is equal to 0 in equation number 1. So what I will get, this term will go off. So I will straight away get V1 is equal to H11I1. So simply what you can do, you can write V1 by I1 which is equal to H11. This is equation number 3. Simply you are getting this one, right? V1 by I1. But V2 by I2, we have to do some calculations. So I will do that. See, now I have to put V1 is equal to 0. See, V1 is equal to 0, I can put here only, right? In this equation only, I can put V1 is equal to 0. And what is my other ultimate aim? I have to find, see, V1 by I1, which is equal to V2 by I2, right? I need to find this ratio. So put V1 is equal, because I can put only V1 is equal to 0 in equation number 1, no other go, right? In equation number 1, not in equation number 2, right? To understand. I don't have V1 here. So if you do so, what you will get? 0, which is equal to, in this equation, it is H11 and then I1 plus H12 and then V2. See, what I need to do with this equation, I will tell you. I am not going to do it here. Anyone, see this one. See this equation now. I will write down. So I2 is equal to H21I1 plus H22V2. See, I need to find V2 and then I2. V2 by I2 in terms of anything. I don't want to tell you anything, right? H22. I don't have any problem with H22. But here I should not have I1, right? I should replace I2 in terms of I1, because I have to replace this one, because I need only V2 and I2. Here I1 is the extra term. I have to cancel this I1 and put I2 in the place of I1. So what you can do? You can do this one with this equation. What you can do? H12 V2, H12 V2, which is equal to minus H11 I1, right? H11 I1. So if you write, I will write here. See this, you can replace this I1 which is equal to, you can bring this one to downside, so it will be H12 minus H11 into V2 into V2. So in terms of V2, anyhow, in terms of V2, maybe I need to find V2 by I2, right? So in terms of V2, I can replace this I1 right now. So if I do so, substitute this one. So this is equation number 4. So substitute equation number 4 in equation number 2. That's all. This is equation number 2. Actually, this is equation number 2. So if you do so, what you will get? So I2 which is equal to H21 is already there. Instead of this I1, you have to substitute this one, H12 divided by H11 into V2 plus H22 into V2. That's all right. Now, if you simplify this one, if you simplify, see here in both the condition, in both things, I have V2 common, right? So I can take V2 commonly outside. So what I will get? I will get minus H12 into H21 divided by H11 plus H22, right? So this will be I2. This will be I2, and I need this one, right? So if you take LCM, what you will get? You will get H11, and if you cross multiply this one, minus H12 H21 plus H22 into V2. Here it is into I2, right? So if you further do this, V2 by I2, you just find what is V2 by I2. So you just bring this one here, this one here. So you will get H11 divided by, see here I have left this one, right? I have made mistake, right? It will be H11, right? H11. I have to multiply. So what you will get? So this one H11 H22 minus of H12 H21. So this is equation number 4, right? I have found what is V2 by I2 and I have found what is V1 by I1. So if you further, I will take these two equations. I have to equate these two equations, right? So 3 equal to equation number 4. What I will get? It is H11. So it will be H11 which is equal to H11 divided by H11 H22 minus H21 H12, right? This is these two equations, right? So here this one and this one will be cancelled out. You can bring this equation to the other side. So H11 H22 minus H12 H21 is equal to 1. This is the condition. And what is this one? What is this one? This whole term. Huh? Maybe this whole term. You know, right? You know, this is nothing but determinant, right? Determinant, right? Determinant of H matrix, right? Determinant of H matrix. What is this one? H11, H12, H21, H22. This is the matrix, right? This is the matrix. And if you want to take determinant of this matrix, what you will do? You will multiply these two, right? H11, H22 minus of, you have to multiply these two, H12, H21, right? That is what we are getting here. That is what we are getting here. So what is the thing here? If you find the H parameter of a two-port network, and if you take determinant of that matrix, and if you are getting 1, then you can conclude that the two-port network satisfy the symmetry condition. Satisfy the symmetry condition. So you can straight away write H parameter that if you take determinant, that value is 1. So this is the condition. If that value is 1, then this is the condition for symmetry. Condition for symmetry. This is the condition. So you have to take determinant. That's all. If you are getting 1, then that will be the condition, right? Then we will go for the ABCD parameter. So what is the equation for ABCD parameter? It is V1 which is equal to AV2 plus BI2, and then I1 which is equal to CV2 plus di2, right? This is equation number 1, and then this is equation number 2. And here I am going to do the same thing. I am going to do the same thing with we put first v2 is equal to 0, v2 is equal to 0 because I have v2 in both equations, right? In equation 1 as well as 2, If I do so, v2 is equal to 0, this equation will go off. So what I will get here, v1 which is equal to, if this one is gone, then it will be v into i2. That is number 1 from 1. And from 2, if I put v2 is equal to 0, then i1 which is equal to d into i2. And if I take the ratio of these two, what I will get? Straight away I am getting, right? So v1 by i1, v1 by i1, divide these two. So this I2 will be cancelled out. So finally I will get b by d. That's all. This is equation number 3. Simply, right? If you put v2 is equal to 0, then you have to put in both equation. If you have voltage in both equations, put in 2. So that you will get this equation, because my ultimate aim is to get v1 by i1 and v2 by 2. See, one thing I have to be very clear, because in ABCD parameter, see here, I will take this one. This current will be in the opposite direction. This current will be in the opposite direction. So the condition for symmetry here, for ABCD parameter, I have to write it in a clear way that it is V1 by I1. No problem with V1 by I1, because I don't have any direction change in the first port. But in the second port, the current is in a different way, right? We have to write it in the opposite direction. So what I will get here? So it will be V2 by minus I2. This is the condition for symmetry. This is the condition for symmetry. Try to understand. This is what we have done for reciprocity also, right? For writing the equations in reciprocity in ABCD parameter, we would have written like this. Maybe V1 by I2 is equal to V2 by reverse of I1, or here we would have put minus I2, right? So condition for symmetry. So this one you have to make it very clear, right? So this is the symmetry, and I have found what is V1 by I1. Now what you do, put V2 is equal to V1 is equal to 0, V1 is equal to 0. So where is V1? Here it is V1, right? So V1 is equal to 0 in equation number 1. There is no V1 here, so you don't need to put anything. So put 0, which is equal to A into V2 plus B into I2 simply. So what you do, you just bring this one to the other side. So A V2, which is equal to minus B I2. So if I write the equation, for V2 by I2, V2 by I2. So you just bring this one here, minus B divided by A, See here, I need to find the reverse of this equation, right? So what you will get? So V2 by minus I2 will be is equal to B by A. So this is equation number 4. Simply what you do now, equate equation number 3 is equal to 4. What you will get if I equate, maybe I will write here, so B by D, which is equal to B by A. So this one and this one will be cancelled out, and if you cross multiply here, so what you will get, it is A is equal to D. Right? This is the condition for symmetry. Right? Symmetry. So what is this one? Maybe this is the ABCD parameter, right? This is A, B, C, D, and if you see A and then B are equal, then you can conclude that two-port network is a symmetry network, right? So we will consolidate now. For Z parameter. What is the condition for symmetry? It is Z11 is equal to Z22. That is the condition for symmetry. And for Y parameter, what is the condition for symmetry? It is Y11 is equal to Y22. And for H parameter, what is the condition for symmetry? it is the determinant of matrix. Determinant of H should be is equal to 1. In other hand, H11 and then multiplication of H12 minus H12 into H21 should be is equal to 1. This is the condition. And for ABCD parameter, what is the condition for symmetry we have seen? That is A, which is equal to D. And these are the four things. If you find any parameter, you see you have a two-port network. If you have a two-port network, then you can find all four parameters, right? All four parameters. You know the procedure to find the parameter values. And if you do so, and if you check out if Z parameter, Z11 and Z22, if both are equal, Y11 and Y22 both are equal, and if you take determinant of H parameter or H matrix, you get 1. Or if you find ABCD parameter, in that if A and D are equal, then you can conclude that the two port network, anyone, if anyone in this particular two port network satisfies this condition, then you can conclude that network is in a symmetry condition. What is symmetry? What is symmetry? It is V1 by I1, which is equal to V2 by I2. That means this is nothing but driving point impedance. Both driving point impedance and is equal. Driving point impedance of the two-port network number 1 and the load impedance of the two-port network 2 are equal. Then you can conclude that. Then you can say that that network is in symmetry condition, right? So we will see some problems in the next class, or we will go for series and parallel cascaded connections, and then we will see some problems in the two-port network. We will see in the next class. Thank you.